So it's pretty obvious where we go from here, right? Sarcopterigi eventually decide they don't want to live in the ocean with all the predators anymore, and they move out onto land. Some lobed finfish that are still alive today have rudimentary lungs that they can gulp air into. They move off onto land, and their fins turn into full on limbs that they use to get around. They develop necks that separate their heads from their bodies, not literally separate, but partition them off. And they get long tails that they can use to defend themselves. That is when you see the tetrapods come about. Tetra meaning four, and pods meaning feet. Things with 4 feet, the tetrapods. So let's look at the first one, the amphibians. These are our first vertebrate that can actually live on land fully. They have their brain, their jaw, they have their skeleton, but now they've got these fancy legs for getting around on land. They develop a respiratory system with lungs so they can breathe the air, and they get this nice 3-chambered heart. So we got a whole extra chamber to work with to pump blood through to the lungs and then back out to the body. Some examples of amphibians are frogs and salamanders and toads. Right here, I've got this nice poison dart frog. This is a species in the rainforest of Costa Rica. And yes, they are very poisonous. If you were to try to eat one, you would probably not make it back to your camp. But there are way less dangerous species like this nice green tree frog, which is actually the state amphibian of Georgia. So very near and dear to my heart, this little guy is. They like to hang out, of course, they like to hang out in trees, but they also like low bushes because there's lots of water there. Then you have the salamander. Some salamanders can be an indicator species. That means essentially we can monitor their population size to keep an eye out for changes in our water quality. So if you start to see nasty stuff in the water, these guys will drop out. They will die off quickly, and that lets us know, hey, there's something wrong with our water. The salamanders are dying, and then we can make some changes, figure out what's going on. Just figured I'd include that as an example of how we use biology to actually get things done. So the big problem with amphibians, the big thing that they have to face, is that they can't really move away from the water yet. And the reason why is that their eggs don't have shells. Let that sink in for a moment. You've got an egg with no shell. You lay it, and you have to let it sit where it is with no protection. Well, if you do that and you don't have any water around, the sun is going to bake it. It's going to shrivel up, and your little babies aren't going to make it. So you have to be near a water source in order to procreate. You have to lay your eggs in the water in order to have them survive. So how do we get around that? Let's take a look.